By the end of this video, you'll know how to build this basic application using the Laravel PHP framework. All you need to know before we start is PHP, including how to use classes and objects, and how to use Composer. I'll explain everything else. To code along with me, you'll need PHP, MySQL and Composer installed, along with a code editor. One of the simplest ways to install PHP and MySQL is to install a package like XAMPP. Composer has simple installation instructions on its website, and if you need a code editor, I recommend Visual Studio Code. These are all free and readily available. Now we have the prerequisites installed, let's install Laravel. If we go to the Laravel repository in GitHub, we can see all the files and folders that make up the framework. Now you could download these files and place them in your project folder. Alternatively, a much easier way to do it is to use this Composer command. So on the command line, let's enter the Composer create project command using the Laravel package. The last part of this command will be the name of the folder where the project will be created. I'll call it Laravel app. I recommend you keep this name simple, with no accented characters or punctuation, and in lowercase. So before we run this, what exactly does this command do? First, it creates a folder called Laravel app. Then it copies the contents of the Laravel framework repository on GitHub to that folder. Then, any third-party PHP packages that Laravel depends on are also downloaded and saved into that folder. Finally, some scripts are executed, which initialize various files and settings within the code. So let's run that, and there we can see the framework and all its packages being installed, and the initialization scripts being run. So there's the folder containing the Laravel project we just created. Let's change into that folder with the cd command and open it using the code editor. There we can see all the files and folders that make up this Laravel project. Don't worry, you don't have to know what all of these do just yet. In addition to using Composer Create Project, there's also a Laravel installer package that you can install, then use it like this to create a new project, which does the same thing. Now we've created the project, let's run the local development server. This will allow us to see the framework running from a web browser. We do this on the command line with the php artisan serve command. So from the project folder we just created, let's run artisan serve. This starts the server at this address. Let's open that in a browser, and we see the Laravel welcome screen. You might see something slightly different depending on your version of Laravel, but if you do see this, then you've got the framework up and running successfully. Next, let's have a look at where this content is coming from. This page is running the index.php script, which is the default, so we don't explicitly need to include it in the URL. If I do, we get the same output. This file is in the public folder. This is the only web-accessible folder in the framework, so this is where you would put any static files like JavaScript, CSS, publicly accessible images, and so on. In a traditional PHP application, to add another page to the site, you might add another file to this folder. For example, let's add a file called hello.php, and inside here, just use echo to output a message. We can then open that in a browser, and we see the message printed out. However, even though you can do this, this is not how Laravel works, so let's delete that file. Instead, let's have a look at index.php. In here, there isn't actually much code at all, and there certainly isn't any of the content we saw when we opened this in a browser. This code is the starting point for loading the rest of the framework. Note that you should never edit the content of this file. So where is the content coming from? In a traditional PHP application, the URL path corresponds directly to files and folders. In Laravel, however, the framework matches the URL path to a list of paths that we specify, known as routes. The framework uses a component called a router to do this. We configure the router to tell the framework what to do when one of these paths matches. We specify these routes in the routes folder in the web.php file. In here, we can see a use statement importing this route class into the current namespace, then a call to the static get method on this class. This method represents an HTTP verb, so you can also use post, patch, delete, and so on. Note that this class in Laravel is known as a facade. You don't need to know how these work in order to use them at the moment, but if you want to, you can read more about how they work in the documentation. The first argument to this method is the path that will be matched to the URL path, and the second argument is a callback function that is what will be executed if it matches. So this is what's running when we go to the home page. We'll come back to this in a moment. To show how this works, let's add another route below, this time matching the /hello path. Inside the callback function, let's just return a string containing a message, including some HTML. If we now go to /hello in the browser, we see that content. So although we can output literal content directly from inside a route like this, this isn't how we do it either. In Laravel, content that we send to the browser, which is typically HTML, is stored in view templates. This is the V in MVC. Views are used to separate the presentation code from the application code. As we can see from the default route above, this is returning the output from calling a function called view with an argument of welcome. So where is this welcome view? View templates are stored in the resources folder, in the views subfolder. In there, there's a file called welcome.blade.php. In here, we can see the HTML content that we see in the browser when we go to the home page. Let's create a view for the hello route we just added. We could create a file directly in this folder, but let's use the built-in generator instead. We're already using the artisan command to run the development web server. Artisan does a lot more though, with many helpful commands to make developments faster. Note that you don't have to use artisan, but it does help. So on the command line, we can get a full list with the artisan list command. To create a view template, we use the make view command. If you want to see the help file for any of these commands, just put the help keyword before it. Let's create a view called hello. This creates a file called hello.blade.php in the resources views folder. In that file, let's delete the default content and just write out a message. Then, back in the web.php file, inside the callback for the hello route we added, let's call the viewHelper function, passing in the literal string hello. This is the name of the view file. The .blade.php suffix is added automatically, so you don't specify it. We'll look at what blade is later on. Note that the view function is a global helper function that's available anywhere in Laravel. There are many helper functions available, listed here in the documentation. Now in the browser, at the /hello route, we get the content of that template printed out. So in this routes file, inside each route callback, you can add as much code as you like. However, if you have more than just a few routes, this will very quickly get long and complicated. Instead, we put application code in controllers. Controllers are just classes that contain methods that run when we assign them to a route. Controllers typically group related logic together. For example, a user controller might handle all requests related to showing and editing user records. This is the C in MVC. Instead of creating a controller class file manually, let's generate one on the command line. Let's create a controller named Product Controller. You don't have to include the word controller in the name, but it's common practice to do so. This has created the controller class file in the app HTTP controllers folder. In that file, we have a class that extends a parent controller class. Now you don't need to do this, but it's useful to have a parent controller class in case you need to extract out any common code. Let's add a new public method to the product controller class called index. In here, we can use the same view helper function we used in the routes file to display a view. First, let's create a new view for this method. Using artisan on the command line, let's make a new view called index, but in a subfolder called products. We can do this by putting a / or a dot. This will create a subfolder in the Resources Views folder and the view file inside that. In that file, let's remove the default content and add a heading. Then, back in the controller, in the index method, we can return this view. To specify the subfolder, again we use a dot. In the web.php routes file, first let's import the controller class into the current namespace with a use statement. The controller is in the app HTTP controllers namespace. Then let's add a get route for the /products path. To specify we want to run the index method inside the controller class, instead of a callback function we pass an array with the name of the class, for which we'll use the class constant, followed by the name of the method, in this case index. So now if we go to /products in the browser, the index method in the product controller class is executed and we see the contents of the index view. In addition to specifying a controller to handle a route, if you just want to display a view and do nothing else, you can use a view route. So let's clean up the routes file, replacing these two routes with a view route to display the home page. We don't need the welcome view file, so let's delete that and rename the hello view to home.blade.php. Inside the home.blade.php view, let's change the title to welcome. So now if we go to the home page, we see the contents of that view. Let's add a link to the product index from this page. In the home view template, let's add a link to the /products URL. In the browser, there's the link, and if I click it, we go to the products page. However, there's a more robust way to do this. Currently, this URL is hard-coded into this link. In the routes configuration file, we can add a name to the product index route. This name can be whatever you like, but it must be unique. Let's call it products.index. Then in the home view, we can use the route helper function, passing in the route name. This will generate the URL to the product's index. The advantage of doing this is that if we change the URL but keep the name the same, we don't need to change any of the links as they'll be generated automatically. In the browser, the link is generated as before. I just used the PHP short echo tag to output the return value from the route helper function. The view templates in Laravel, however, use the Blade templating engine. So in addition to being able to use PHP, Blade includes several shortcuts with simpler, more concise syntax. To display a value, we use two sets of curly braces. So let's convert this to use the Blade syntax. This works just as before. Blade also makes it much easier to include common code, like a header and footer. At the moment, we just have this HTML code in these view templates. But to make this a complete HTML document, we should include HTML tags, head and body sections, and so on. This code will be common to all of these views. Instead of repeating ourselves in every template, however, using Blade, we can create a common layout. We can do this using components or template inheritance. Let's see how we do this with components. These are reusable, self-contained chunks of interface code. We can generate a new component with the make component command. However, this will also generate an associated class that we can use to add functionality to the view. For the layout though, for now we just want the view template. So we'll pass in the view flag to create what's called an anonymous component. We'll look at this in more detail later on. So let's create an anonymous component called layout. This creates a file called layout.blade.php in the Resources Views Components folder. In here, let's remove the default content and add some basic HTML with head and body elements. Then in the Products Index view, we wrap the content with HTML-like tags that start with an X, followed by a hyphen, then the name of the component, in this case layout. Whatever is inside this tag will be passed to the layout. To display this content in the layout, we output a slot variable, using the syntax we saw earlier for displaying variables in Blade templates. Now in the browser, we get the contents of the template inside the layout. To quickly add some styling to this, we'll use a classless style sheet. So let's copy this code and paste it in the head section of the layout view. Now we get these styles applied to the page. I know Laravel is heavily integrated with Tailwind CSS, but that's beyond the scope of this video. The advantage of using a classless style sheet is that we can have some nice styles while developing the backend, and we can style it later on. Let's include the home view in the layout. And now that has the common layout, including the style sheet. Now we have a product page, let's show some data on it. The data will come from the database. So first we need to configure the framework to connect to the database. By default, this version of Laravel uses an SQLite database. I'm going to change this to use a MySQL database. We define these settings in a file called .env in the root of the project. Note, these are just keys and values, this isn't PHP code. In that file, let's find the DB connection setting and replace SQLite with MySQL. Let's also uncomment the host, port, database, username and password settings. If any values like the port, username or password to your database are different to these defaults, then here is where you need to specify them. This will use a database called Laravel. Note that a database with this name doesn't exist yet on this server. Next, we need to add a database table to store product data. In a traditional PHP application, you might use a tool like phpMyAdmin to create the database, and then a table inside that database. Instead, in Laravel, we use migrations to create and modify database tables. Doing this allows you to include the database schema inside the codebase, so it's easier to keep it inside version control, and much easier for multiple developers to use the same database structure. To generate a migration, we use the make migration command. So on the command line, let's create a migration called create product table. Note that the name of the migration file isn't a PHP class name, so we typically use snakecase. This creates a file in the database migrations folder with the name that we supplied, but the file name that's generated starts with the current date and time. This is so that Laravel knows in which order to run the migration files. In that file, we have a class that contains two methods. The up method is used to modify the database, create tables, add columns and indexes to existing tables, and so on. The down method should do the reverse of what the up method does, so removing a column that was added, deleting a table, and so on. Inside these methods, the Laravel schema builder is used to create and modify tables. There are methods to create tables, add columns, rename tables, and so on. In both of these methods in the migration, the generator has worked out that we want to create a table called product, based on the name we gave the migration file. So using the create method of the schema builder, we pass in the name of the table, followed by a callback function whose argument is an object that represents the table. By default, an ID column is added using the ID method. This creates an auto-incrementing integer column called ID. The timestamps method adds timestamp columns called createdAt and updatedAt. These are optional and you can delete them if you like. There's a list of the available column types in the documentation. Let's add some columns to this table. Let's add a string column called name, which in MySQL will be a varchar. The default length is 255 characters, but you can specify the length with the length argument, which we'll set to 100. Then a text column called description. By default, columns don't accept null values. You can specify this by adding a call to the nullable method. Then a decimal column called size, with a precision or total of 8 digits, and a scale or number of decimal places of 2. Let's also use a column modifier to set a default value of 0 for this column. As with the column types, there's a list of available column modifiers in the documentation. In the down method, we want to reverse this migration, so drop the product table. The generator has created the code to do this for us. Before we run this, note that the database migrations folder isn't empty. There are already some migrations in this folder that will create some default tables that are used by the framework for typical operations: cache, jobs, and users. You can just leave these in. So on the command line, let's run the php artisan migrate command. If you haven't created the database yet, as we haven't, then the script detects this and offers to create it. Let's say yes, then the migrations are executed. If we have a look at the database server, there's the database that's been created, and it contains several tables. Several related to caching, jobs, and users, but there's the product table with the structure we specified. Also note a migrations table has been created. This will be created even if you do remove the default migrations, as this is used internally by Laravel to keep track of migrations. If for some reason you want to undo a migration, you can run the rollback command. This will undo the most recent batch of migrations, running the down method in each migration class. If we have a look at the database now, we can see that the only table left is the migrations table. Note that the database isn't removed if it was created automatically, as this wasn't explicitly created using a migration. Let's run those again, and it recreates the tables. So now we have a product table to store product data. For now, let's insert a couple of records manually using phpMyAdmin so that we can see how to retrieve this data using Laravel. I'll include some HTML code in the description of one of them so we can see how escaping works later on. In a traditional PHP application, you might connect to the database using MySQLi or PDO, then use that to run an SQL query to retrieve some data. You might even do this in the same script where you're displaying it. So in this case, it would be here in the product view. Not so in Laravel. The view is just used to present some data, containing just enough logic to do so. In the controller, when we render a view, we pass the data to the view that we want it to display. We also don't retrieve the data directly in here, however. To interact with the database, we use models. Each database table has a corresponding model class. This is the M in MVC. Laravel includes an object relational mapper component called Eloquent. This means that most of the time you don't need to write SQL queries directly, as it includes methods to retrieve, insert, update, and delete records. To generate a model class, we use the make model artisan command. Note that as models typically correspond to a single database table, you can create a migration at the same time as the model by passing the migration flag. As we've already created the product table, we don't need to do this. So let's run that command to create a product model. This creates the class in the app models folder. The class that's generated extends the base Eloquent model class and uses the hasFactory trait. This trait is included so that model factories can be used when testing. Other than that, there isn't any other code in this class. In the product controller, in the index method, let's use this model class. So first, let's import it into the current namespace with a use statement. Then, back in the index method, to get all the records, we simply call the static all method on the product model class. Before we do anything else, let's see what happens when we run this. We get an error message saying the products table doesn't exist. By default, Eloquent will try and guess the table name based on the model class name, assuming the model is singular, so the table name will be plural. So in this case, it guesses the table name as products. The table name we created using the migration is just called product, however. You could rename the table using a migration, but instead, let's configure the model with the actual table name. We do this by adding the protected table property, which we'll set to the string value product. Now in the browser, the error has gone. Let's see what values the all method has returned. To do this in traditional PHP, you'd probably do something like this. Use vardump to output the contents of the variable, then die to stop the script. When we run this, we get an Eloquent collection object that contains two product model objects, each one corresponding to a record in the database. You can see the values of the columns among all these properties. To quickly see some values like this by using vardump then stopping the script, Laravel provides a helper function called dd, which stands for dump and die. This outputs the same information, but also formats it, so you can expand the various properties, making the output much clearer. So now we have the data. Instead of outputting it like this, let's pass it to the view so we can display it. To pass data to a view, we pass an array as the second argument to the view function. The index of these array items will be the name of the variable in the view. Then, in the product's index view, we can display the data. Using plain PHP, one way to display the data would be like this, using a for each loop, and inside the loop, using the PHP short echo tag to output the various properties of each product model object. As the text values could contain untrusted data inserted by users, then we typically need to escape them using the HTML special chars function to avoid a code injection attack. When we run this, we get the details of the two models printed out. As we're using Blade templates, however, these provide shorter syntax for common tasks like loops. So let's convert this plain PHP code to use the Blade syntax. Using the shorter syntax to output values has the added advantage of this data being automatically escaped, so you don't need to use a function like HTML special chars. In the browser, the output is the same. Back in the controller, we can also clean this up a little bit. Instead of creating a variable to store the product data, we can just assign the product all call to this inside the array we're passing to the view. And in the browser, this works as before. So we've retrieved and displayed this data without writing any SQL at all. If you want to see the SQL that was generated and used by the framework, then one of the easiest ways is to install the Laravel debug bar. This is a third-party component that gives you lots of details about each request when developing. To install it, we do it with this composer command. So let's run that on the command line, making sure we specify the dev flag so this is only installed in development, as we don't want this to be running in production. Once that's installed, if we refresh the page, we get the debug toolbar at the bottom. In the Queries tab, in addition to some default queries related to the session, we can see the query that retrieved the data from the product table. As well as details about the queries, we can see which views were rendered, details about the request, and much more. Next, let's see how we insert data into the database using Laravel. First, let's add a method called create to the products controller to display a form for entering product data. In here, let's return a view called create in the products folder. On the command line, let's generate that view template. In that template, let's use the layout component and add a heading and a form that uses the post method. Inside the form, let's add a text input and associated label for the product name, a text area and label for the description, and a text input and label for the size. We'll end the form with a button. Then in the routes configuration file, let's add a new getRoute. For the path/products/create, that runs the create method in the product controller, and we'll assign the name products.create. I won't create a view route like we did for the home page, so we keep all the functionality inside the controller. Finally, in the products index view, let's add a link to the new product page using the route helper function with the name we assigned to the route. In the browser, on the product index, there's the link, and if I click it, we see the new product page. Now we can add a method to handle the form submission. In the controller, let's add a new method called store. Note that you can call these methods whatever you like, but these names are the convention for operations like this. The first thing we need to do in this method is get the data from the form. In a traditional PHP application, you'd use the post superglobal, something like this. In Laravel, however, this data is encapsulated as part of a request object. To get access to this object, we just need to include it as a parameter to the method. When the controller class was generated, a use statement to import the request class into this namespace was included, so we can just add a type declaration to this argument of the request class. To get the form data from the request object, we can use the all method to get all values, or the input method with an argument of the input name to get an individual value. So instead of using the post superglobal, we could get the value of the name input like this. You can also use dynamic properties. So for example, we could just access the name property of the request object to get the same value. To insert a new record using Eloquent, we create a new model object, then assign values to properties. The names of these properties are the names of the columns in the database table. So let's assign values from the request to the name, description, and size attributes. Then, to save the new record, we simply call the save method. After that, let's use the redirect helper function to redirect back to the index page, using the named route for that page. Note that you have to return this for this to work. Before we try this, we need to link this to the form. So in the routes configuration file, let's add a route to run this method. This time, however, it will be a post route, as the form uses the post method. Then in the create view, let's add an action attribute to the form, again using the route helper with the named route for the store method. Let's give that a try. If I enter some data into the form and submit it, we get a 419 page expired error. This is part of Laravel's built-in cross-site request forgery, or CSRF protection. The framework will generate a unique token for each user session, which verifies that the request comes from the current user. This is all enabled by default. All you need to do is make sure you include a hidden field in your form that contains the token value. You can do this manually with this code, or include the @CSRFBlade directive in the form. So inside the form, let's add that directive. Let's try that again. If I enter data into the form, we're redirected back to the index page, and we can see the new record that's been inserted. There's an alternative to creating a new object, setting properties, and calling the save method like this. Instead of all this, we can just call the static create method, passing in an associative array of all the values we want to save. We can get this from the input method on the request without passing in any arguments. Let's give that a try. Now we get an error saying we need to add the fillable property to allow mass assignment. A mass assignment vulnerability is when unexpected data in the request changes a column in the database. For example, when editing users, there might be a column in the user table that gives a user admin permissions. A malicious user could send a value for this column when creating a user record that would give them admin access. To prevent this, we add a property to the model that lists the columns that are mass assignable. So in the product model, let's add that property, and for its value, an array containing the column names that we want to allow to be mass assignable: name, description, and size. Let's try creating a new record again, and now it works. Let's have a look at the product records in the database. In addition to the values we specified in the form, note that the created at and updated at columns have been set to the current date and time. The values for these columns are set automatically when you create and update a record. If you don't want this behavior, you can set the timestamps property on the model to false. So now we can insert a new record. Watch what happens though if we submit an empty form. We get an error coming back from the database as the name column cannot be null. So we need to validate the data in this form before we try and save it. In the create method in the controller, we can validate the data in the request by calling the validate method on the request object. The argument to this method is an array containing validation rules, one element for each field. The index of the element is the name of the value in the request, and the value is a list of validation rules. There are many available validation rules for validating a particular data type, minimum or maximum length, and so on. So let's validate that the name field is required, in other words, it can't be empty. Let's also make it a maximum length of 100 characters, in line with the size of the field we created in the migration. We separate multiple rules with a pipe character. The description column can be null, but if it is present, let's say that we want at least 3 characters. Using the nullable validation rule will allow the field to be empty. We'll validate that the size is required, is a decimal value with between 0 and 2 decimal places, and that it has a maximum value of 100. If you prefer, you can specify the validation rules as arrays instead of a single string with pipe characters. Let's give that a try. Now if I submit an empty form, we no longer get an error, but the form is simply redisplayed. When validation fails, the framework will redirect the user back to the previous page. In addition, the original request input and error messages will be made available to the view. The errors variable that contains all the validation messages is an instance of the MessageBag class, which has convenient methods like all that will return an array of all the error messages. So in the create view before the form, first let's check to see if there are any errors, so that this error display code isn't executed the first time we display the form. Then let's loop around the list of errors, displaying them in an unordered list. So now if I submit an empty form, the form gets redisplayed with the validation messages at the top. If I do supply values for these, but these values are invalid, then we get the relevant validation messages. Note, however, that when the form is redisplayed, the original values entered into the form are lost. Laravel provides a convenient helper function called old that we can use to display these values. So in the form, let's add a value attribute to the name input, and for the value, we'll call the old function with a value of the name of the input. Let's do the equivalent for the text area and the size input. So now when we submit the form with invalid data, the originally entered values are preserved. If I submit valid values, then the record is saved as before. Next, let's see how we can view an individual record. First, let's create a view to show a product. Then, in the product controller, let's add a new method called show. In here, we'll display the view that we just created. Then we need the data of the individual record to pass to the view. We're going to identify the individual record with its ID in the URL. So far in the routes config file, all the routes we've defined have a fixed path, with segments consisting of literal strings. To add a variable segment, known as a route parameter, we enclose the segment in curly braces. So let's add a new get route with a path that contains a route parameter for the product ID. This will run the show method in the product controller, and as above, let's add a suitable name. When this route matches, the value of the route parameter will be passed to the show method as a parameter to that method. So in the controller, let's add a parameter to the show method for the ID. We can add a string type declaration to this, as the URL is a string and the value of this is part of the URL. Inside this method, for now, let's output the value of this parameter. Let's try that. If I go to a URL that matches the route we just added, we get the value of the second URL segment printed out. In this case, 123. This works for any value that I put in this segment of the URL, including non-numeric values. However, in the database, the product ID column is an integer, so there's no point in matching this URL when the ID isn't an integer. In the route configuration file, when we define the route, we can add an optional constraint on the route parameters using a regular expression. So for the show route, let's specify that the ID should match this regular expression, which says that the ID must be at least one digit. Now in the browser, if the route doesn't contain a numeric ID segment, it doesn't match and we get a 404 not found response. It does match if the segment is numeric, however. Some commonly used regular expression patterns have helper methods to make it simpler to add constraints to parameters. So for a numeric parameter, instead of this regular expression, we can just use the whereNumber helper. And this works as before, matching numeric IDs, but not ones that aren't numeric. There's a list of these helper methods in the documentation, along with how to use other characteristics of the router like optional parameters. So now we have the ID of the record we want, we can use the model to retrieve the record with that ID. We've already used the all method to get all of the records. In Eloquent, each model object serves as a query builder, allowing us to build up an SQL query with constraints, order by clauses, and so on. Let's get the product record using the query builder to see how it works. So instead of outputting the ID, let's use the query builder to perform a query. As we're using the product model, this will perform the query on the product table. We'll select all the columns with a constraint on the ID column. In the browser, if we supply an ID that we know exists in the database, we don't see any output in the browser window as we haven't explicitly output anything. But if we use the debug bar, we can view the query that was executed. Select star from product where ID equals 1, which is the value of the ID in the URL. You can use the select method to select specific columns, but all the columns are selected by default with the asterisk, so we can remove that. The Query Builder allows us to build complex queries that generate whatever SQL we need. Check out the documentation for all the options. However, instead of building up a query like this, the model gives us a method called find, which retrieves a model using its primary key. So all we need to do is call the find method on the model class, passing in the ID. In the browser, this runs the same SQL, although it has added a limit clause to limit the results to one record. Now we have the product record, let's pass this to the view for display. So let's add a second argument to the view function, passing in an array with an index of product and the value of the product variable. When passing data to a view like this, where we pass an array where the index has the same name as the variable, there's a common shortcut that's used to simplify it. The compact method in PHP will return an array where the name we pass in is the index and the value is the variable with that name. This is the equivalent of what we just wrote, so we can replace this code with this call to the compact function. Then in the show view, let's replace the default content with some simple code to display the product, using the layout component to enclose the markup. Let's try that with an ID that we know exists in the database, and we see the product details printed out. Let's try that with an ID that we know doesn't exist, and we get an error, saying we're trying to read the name property on a null value. This is because if the product record isn't found, the find method returns null. So we can check for this, and if so, let's show the 404 not found page. To do this, there's an abort helper function, which will throw an HTTP exception for the given code. The framework's exception handler will catch this and display the 404 page. So now if the record isn't found for the specified ID, we get the 404 page. However, as this is a common task, we can achieve the same result by using the find or fail method. This will return a record that matches the given ID or throw a 404 exception. So with this, we don't need the code that checks to see if the product variable is null. The idea behind writing all this code to get the product model that eventually was reduced to just one line was to show you how there are several ways to do things in Laravel, but often for common tasks there are helpful shortcut methods. So now if the record doesn't exist, we still get the 404 response. If the record does exist, we see its data on the show page. There's a way we can reduce this code even further. At the moment, the router is passing the ID from the root parameter to this method as an argument, and we're looking up the product record based on this ID. As doing this is also a common task, there's a more convenient way to do this using root model binding. This allows us to automatically find a model instance that has an ID that matches the value in the URL, getting the class of the model from the type declaration in the controller method. So in the show method in the controller, instead of a string argument for the ID, we'll specify an argument of the product model class called product. Then in the root's config file, instead of the ID root parameter, we'll specify a root parameter with the same name as the argument to the show method we just changed, which is product. This will automatically look up the product record based on the ID value in this segment. As the ID is a number, this also automatically doesn't match the root if there is a non-numeric value in that segment, so we don't need to use the whereNumber constraint either. Back in the controller, now the model is being passed into the show method from the router, we no longer need to use the find or fail method to look it up. If a matching record is not found in the database, a 404 HTTP response will be automatically generated. Let's give that a try. Viewing an existing record works as before, and if I try an ID that doesn't exist, we get the 404 not found response. Now we have a page to view individual products, let's link to that page from each product on the index page. So on the line where we're outputting the product name, let's wrap the name in an anchor tag. For the URL, we'll use the root helper, passing in the name of the root, and for the second argument, the product ID. This will insert the ID of the product into the segment that contains the root argument for the product. So now each product on the index page links to the corresponding show page for that product. Next, let's add functionality to edit an existing record. First, let's make a view template to show the form for editing a product. In that view template, let's replace the default content with just a heading for now, enclosed in the layout component. Then in the root configuration file, let's add a getRoot to show this page, using root model binding as we did in the show root to get the product record. This will run the edit method in the controller, which we'll add in a moment, and we'll give it a suitable name. Then in the product controller, similar to the show method, let's add an edit method with a product model object as an argument. In the body of the method, we'll display the edit view, passing in the product model. Finally, in the show view template, let's add a link to this page. So now on the show page, there's the link to the edit page, and clicking it shows us that view. Inside this view, we want to show a form to edit the product details. We already have a form in the Create view that contains the necessary fields, along with the code to display validation errors. So instead of repeating this, let's reuse it. As with the layout that we created earlier, we'll do this with components. So on the command line, let's create a new component called Form in a folder called Products. We only want the view template for this, so we'll pass in the view flag. Let's also create a component called Errors, again just the view. This has created the Errors view in the Views Components folder, and also a folder called Products, and a form view file inside that. So here in the Create view, first let's select the code that displays the validation errors, cut it, and paste it in the Errors component view, replacing the default content there. Then, back in the Create view, at the point where we just cut that code, we'll include the Errors component with the xErrors tag. Then, let's select the contents of the form, cut that, and paste it in the Form component view. Back in the Create view, we'll include this component with the xProducts.form tag. So all we've done for now is to extract parts of the form for creating a new product out into separate components. Let's check that still works by creating a new record. If I submit invalid data, we see the validation messages, and the previous data is still redisplayed in the form. Now we can do the same in the Edit view. Let's copy this code from the Create view that includes the Errors component and the Form tag. We'll paste this into the Edit view. When we submit this edit form, we don't want to run the store method, so let's just remove the value of the action attribute for now. So now if we select a product and go to the Edit page, we see the form. However, we need the fields to be filled with the existing values of the record's properties. In the Edit method in the Product controller, we're passing the Product Model object to the view. So in the form, let's try using this variable. In the value attribute of the name input, we're using the old function to redisplay previously entered data in this input. The second argument of this function lets us assign a default value to return if there isn't any previous value. So we'll pass in the name property of the product object. When we run this, we get an error saying that the product variable is undefined. We're including the form components from the Edit view. We have access to the product variable from this Edit view, but variables aren't automatically passed to included components. To pass data to a component, we use HTML attribute strings. To pass a PHP variable, however, we need to prefix this with a colon. So let's pass the product variable to the component using the same name. Now in the browser, the error has gone, and the name input contains the existing property value. Let's do the same for the description and size inputs. So now in the browser, when editing a product, we see its existing property values. However, if we go back and view the New Product page, now we get an error saying the product variable is undefined. One way to fix this will be to pass in a new product model instance when we render this component from the Create view. This would have blank values for the properties. Another way to fix this would be to use the null coalescing operator to return a default value if the model variable isn't defined. Let's go with this way for each of the three inputs. Now the error has gone and the new product form works as before. Next, in the Edit view, we need to add a value to the action attribute of the form to handle the form when it's submitted. First, let's add a method to the product controller. We'll call this method update, and as with the store function, we'll pass in the request so that we can get the form data, and also a product model to identify the record we're updating. Then in the routes configuration file, let's add a route that uses the patch method, includes the product in the URL, and runs the update method in the product controller. We'll also assign a suitable name. Then, back in the Edit view, we'll output this route in the action attribute, making sure we pass in the product variable. However, we can't change the method to patch in here, as HTML forms don't support it. We can spoof this by adding a hidden field with the name of _method with the method we want to use, or we can use the @method blade directive. So let's add that to the top of the form, specifying the patch method. So now in the edit form, if we view the source, we can see the URL in the action attribute includes the ID of the product, and there's a hidden field to spoof the method. Now we can add code to the update method to process this form when it's submitted. In the store method we use when creating a new record, the first thing we're doing is validating the form data. We want to do the same thing in the update method, but without repeating this code. So we don't repeat this code, we can create a form request class to encapsulate the validation rules. We can do this with the artisan make request command. So on the command line, let's make a request class called save product request. This creates the file in the app HTTP requests folder. In that class, there are two methods generated by default. The authorize method is used for authenticating users, which we're not going to use in this video. We do need to change its default return value to true though. The rules method returns the validation rules that apply to this request. So in the product controller, in the store method, let's copy the contents of the array that contains the validation rules and paste these in the rules method of the save product request class. Then, back in the product controller, to use this class, first let's add a use statement at the top to import it into the current namespace. Then let's change the store method to use this class. First, we'll change the type declaration of the request argument to the save product request class. Doing this will validate the request data automatically, using the rules we added to that class, before the controller method is called. If validation fails, a redirect response will be generated, and the errors will be available for display as before. So we can remove this call to the validate method. Then, to get the validated data, instead of the input method, we call the validated method. This returns the values that have been validated. Note that if you have any fields that don't have any validation rules, these values won't be returned from this method. So you'll need to get those from the input method we were using before. Let's give that a try. If I submit an empty form, we get the validation errors as before. If I enter valid data, this also still works. Now we can do the same in the update method. First, we'll change the type declaration of the request argument to the save product request class. Then, inside the method, to update the product, we call the update method on the product object, passing in the validated data from the request. Note how we're calling the method on the object and not on the class like we did in the store method. Then let's redirect back to the show page for that product. Let's give that a try. Let's edit a record and submit a form with invalid data. We get the form redisplayed and the originally entered data is preserved in the form. If I submit valid data, the changes are saved and we're redirected back to the show page for that record. Let's also redirect to the show page after inserting a new record. At the moment, in the store method, after storing a new record, we redirect to the index page. To get the newly inserted record, the create method will return a product model object. So let's assign that to a variable. Then we can change the redirect to the show page, passing in the product to the root helper function. Let's give that a try. Now when we insert a new record, we're redirected to the show page for that record. Next, let's add functionality to delete a record. First, in the product controller, let's add a new public method called destroy, which has an argument for the product model. Inside this method, to delete a record, we call the delete method on the model object. Once we've done this, let's redirect to the product index page. Note that you could of course call this method delete if you prefer, but it's convention to call it destroy. Then in the routes file, let's add a route that uses the delete method that runs this method in the controller. Then in the show view, let's add a form to run this method. We can't use an anchor tag like the edit link, as plain anchor tags can only make GET requests. As with the other form, we'll include the CSRF token, and we'll also spoof the HTTP method to be delete. All we need inside the form is a button. Let's give that a try. If I select the first record on the index, on the show page, there's the delete button. If I click it, we're redirected back to the index, and we can see the record has been deleted. To make this more user-friendly, let's output a message here to say that the record has been deleted. One-time messages like these are typically done by saving a value to the session, so it's available in the next request. This is known as flash data, as it's automatically removed after the next request. We can set a flash message in the session by getting the session from the request object. However, as it's a common task to redirect and show a flash message on the next page, there's a convenience method to do this. We can then display this message in the template with Blade syntax like this. So in the destroy method in the controller, when we return the redirect response, let's set a message with a key of status. Then in the layout view, let's add code to display this message from the session if it exists. Let's give that a try. If there's no flash message, then nothing is displayed. If we delete a product, when we are redirected back to the index, the message is displayed at the top. If I refresh the page, making a new request, then the flash message is gone. Let's add similar messages to when we save a new record in the store method, and when we save changes to an existing record in the update method. Now when we create a new record, we see the flash message after we've redirected to the show page for the new record. Likewise, if we edit it. Now that we've added several records, we can see on the index page that it would be better to paginate these results rather than show them all at once. In the index method in the controller, instead of calling the all method on the product model class, let's call the paginate method. The default number of records per page is 15, but you can change that by passing an integer argument to the paginate method. Let's pass in 3 so that we can clearly see the pagination working. Now in the browser, we only get the first 3 records returned. So next we need some navigation links so that we can move between pages. In the index view template, we can do this with the links method on the product variable. Now in the browser, we get some navigation links that allow us to move between pages, along with a message saying which records are being displayed. Note how the current page is automatically passed between pages using the query string. If we use the debug bar to see the query that's been generated for this, we can see that it now includes a limit and an offset clause. By default, the markup for these links includes lots of HTML and CSS, so it's compatible with the Tailwind CSS framework. If you don't want to use this, you can specify the name of a view template when calling the links method. You can define your own view template, and there are several methods you can call on the object you're paginating. For example, to get the current page, the next page URL, total number of pages, and so on. Laravel includes several templates for pagination with different CSS frameworks, and a couple of basic templates. The simplest way to customize these is to use this artisan command to copy these from the framework itself into the application. So let's copy this command and run it on the command line. This copies the templates from the framework code to the Resources Views Vendor Pagination folder. In that folder, there are several view templates for pagination with frameworks like Bootstrap, Tailwind, and so on. The simplest one is called Simple Default. This contains simple markup to generate the pagination links, using some of the available methods we just saw in the documentation, such as hasPages, previous page URL, and so on. To use this view, in the index view template, let's pass its path to the links method call. Now in the browser, we just have previous and next links to move between pages. If you want to set this view as the default for pagination, you can do this in the App Provider's App Service Provider class as shown. If you do this, you don't need to pass the path to the view template when you call the links method. Now these templates are part of the application, you can edit them, move them to another folder, rename them, and so on. For example, in the Simple Default template, let's add some inline CSS to the unordered list element to display the links horizontally without any bullets. Now in the browser, the links are on the same line with no bullet markers. Going back to the debug bar to view the query, note that no order by clause has been included in the query. We should include an order by clause so that we can guarantee the order of the results. So in the controller in the index method, let's add a call to order by, ordering the results using the created@ column. Note that you have to call this before the paginate method. Now when we run this and look at the query, the order by clause has been added. So now we've implemented the basic operations to view, insert, edit, and delete records. In the routes configuration file, here are all the routes we've defined to do this. As you can imagine, with many more routes, this list of routes could get quite long. Apart from the home route, all these routes have common elements, such as the controller and the first segment of the URL. We can define routes in groups to share common attributes, which will make the route configuration file simpler. Before we do that, first on the command line, let's view the list of current routes that we've defined. We do this with the artisan route list command. For each route, we can see the HTTP method, the path, including any route parameters, the name, and the controller and action that will run when the route is matched. As well as the routes we've explicitly defined, there are some routes that have been added by the debug bar, and these ignition routes are used for exception tracking in development, but you can safely ignore these. These are the ones we've defined for dealing with product records. As these routes share the same controller, let's add a route group that uses the controller method to define the common controller. We pass a closure to the group function and define the routes inside that group inside that function. So now we can remove the controller from the routes inside this group, and just specify the method inside that controller for each route. This is already making the routes file much simpler. If we look at the list of routes again on the command line, we can see nothing has changed. The routes are exactly the same. And if we try the application in the browser, it still works as before. Another thing these routes have in common is that they all share the same products prefix in the first segment of the route path. We can specify this with the prefix method. So now we can remove this prefix from all the routes in this group. Again, this hasn't changed the defined routes, they all still have products as the first segment. Another thing these routes have in common is the prefix of products and a dot on all the names. We can specify this in the group with the name method. Then we can remove this prefix from each name. And again, the list of defined routes is still the same. And the application still works as before. Now, however, the list of routes is much simpler. To get to this point, we created a migration to create the product table, a product model so that we can interact with that table, and a product controller to handle the requests and responses. We initially generated all these files individually on the command line. Let's have a look at the help for the command to make a new model. In addition to generating a model class, we can also make an associated migration and controller at the same time. Let's generate a new model class to see how this works. Let's make a model called category, adding the flags to make a migration, a controller, and the R flag to make the controller resourceful. We'll see what this means in a moment. When I run that, we get a model, a migration, and a controller. The migration has been generated as we saw before, with up and down methods, the table name, the plural of the model name by default, and ID and timestamp columns. All we need to do is add the columns we need and run the migration. The category model class extends the Eloquent model class, so all we need to do to get this working like the product model is add a fillable property for the columns we want to be mass assignable. In the category controller, we can see that this already contains several methods. These methods are exactly the same as the ones that we created for the product model. Index, create and store, which includes the request as an argument, show, which includes a category model as an argument, and similarly the edit, update and destroy methods. All we would need to do is add the code for each method. As we can see in the product controller, this isn't very much code at all, as the model methods take care of most of the database code. We do need to add routes for this to work, and we could do this in the same way we added routes for the product controller. As this is a common pattern, however, we can define these routes with a single line in the routes configuration file. When we generated the controller just now, we specified that it should be a resource controller. This route method is compatible with the methods that are generated in that controller. So in the routes configuration file, first let's input the category controller class into the current namespace with a use statement. Then we can add a resource route specifying the URL prefix as the first argument, then the controller class. Let's have a look at the routes that this has generated. They follow exactly the same pattern as the product controller routes we defined individually, including the route names. The only difference is the route we defined to store a new record. We defined it as a post route to the URL path /products/store, but the equivalent resource route generated is just to /categories. So by generating the model, migration and controller at once, you can create functionality to create, read, update and delete records very quickly with a minimum of code. That concludes this particular tutorial, but if you want to see more tutorials on any specific topic, please let me know in the comments. Please don't forget to like and subscribe, and as always, thank you for watching.